Welcome back again after the lunch break. I hope you all enjoyed the lunch and the sun. We'll be back with Helmut, and he's going to talk about debvm. So enjoy the next 20 minutes.
Thank you. So this is a repeat talk from Chemnitzer Linux Tage. If you have been there, please have a nap instead. Below there is the slides. So in case you're sitting behind a bar, you can follow the slides on your screen. And without further ado, I'll introduce the introduction. It's pretty simple. What is debvm? How to use it? Why to use it? And what to use instead? Pretty simple. So one more thing. I'll talk about me. I'm not maintaining packages. Well, except one happened to follow me. I'm working on things I have no clue about, but eventually may have, or may have seen that. In that process, I occasionally break the Debian archive. I'm sorry about that sometimes. I'm freelancing, so in effect that means I can be bored. And I'm usually collaborating with Freaksian. So that's it. In order to talk about debvm, we need to have understanding of two relevant tools, and one of them is mmdevstrap. Can I have a quick straw poll about whom of you knows mmdevstrap? That sounds about good. So you basically know what it is about. It's a C debstrap replacement. It does a little bit more with hooks and flexibility and cross and all of the sorts. It's good that you know. We'll be using it a lot here. The other is Qemu. Wait. Straw poll about Qemu? Good. You don't have to tell more. You all know it already. That was better than in Chemnitz. So the idea of debvm is plug these two together in a cool way. The second idea is expose the underlying tools for customization in as much as possible, which is why the respective debvm tools are actually wrappers, and you can pass your own mmdevstrap and Qemu options through them. Next, and that's probably most critical thought here, is avoid bootloaders. When you try to do VMs, you always have to mess with like grub or efi or whatever not, and if you're doing RM, it's uboot or something else, and that's a quite diverse ecosystem, and instead debvm uses Qemu as bootloader, so it plugs a kernel image and an init.rd directly into Qemu, and that way avoids this entertaining topic altogether. Yeah. And the final thought here is I want to represent a VM as a single file, and that single file is the file system image, and everything is in there, well, except for the bootloader. So how do you use it? It's two commands, essentially. One of them is debvm create. That's the mmdevstrap wrapper, apparently. And that one creates your file system image out of nothing. Well, you download packages from the mirror in the way you like, and then you have this rootfs thingy. And in order to use that, you can debvm run it, which essentially means call Qemu in a useful way, that it extracts the actual kernel from that file system image and passes it to Qemu. So it's not doing that much, actually, some lines of shell script. Some basic examples. So if you're working for some ELTS company, you may be interested in doing something with old releases, and yeah, you can do that. It still works, powered by mmdevstrap. I'm not doing much about that. If you're interested in other kinds of architectures, you just tell mmdevstrap to do so. The double dash over there says, this is the end of debvm options, now it's mmdevstrap options. So we just pass that through, and you can also do multi-arch over here. So this tells it, I want an i386 VM, but I also want MD64, and when it goes to the kernel selection, it sees, I have MD64. Let's better prefer the 64-bit kernel for that i386 VM. So you can plug more RAM into it. And if you happen to not be enjoy it with systemd, you can also say, I want to try system 5 or Finit or whatever other in your system. If I'm missing out on one, maybe fallback or that. Then sometimes it's not convenient to interact with your VM through Qemu directly. So a common pattern I've experienced was that I would like to SSH into it. So you can pass the creation step a pub key, and that causes it to put it in the right location for root, and also install an SSH server, which is convenient. Then when you run it, you tell it you want a port for that, and it does this user mode networking by default and forwards this port outside, so you can just SSH into it after having waited for SSH to be ready, which turned out to be not entirely trivial, so it has another wrapper for it. And then you just SSH there and can do whatever you want without typing passphrase or like that. Hope that solves your use case. Maybe you want to do some testing. So if you dislike OpenQA, OpenQA is great. Or maybe you don't want to run this continuously, but just try like a GNOME desktop. You can do that as well. Beware that if you go graphical, you can't use the cloud kernel image. You have to use the generic one, so we include that here. It also disables recommends by default. That's an mmdevstrap thing. So we enable them. This one is a standard hook, which basically says add a dummy user. And the only option left over there for debvm create is the size, because the default size is too small for the desktop image. And running it is then graphical. Yeah, which basically goes like, doesn't use the console, which it does by default, but spawn the graphical interface. Beyond that, we may be interested in running Ubuntu. It wasn't as easy as I had hoped it to be. This is an example for Kinetic. You pass the keyring and the components. It doesn't work without Universe. And they still have a bug that they have a missing dependency on x2fs procs. Yeah, since that is usually installed on it, it seems to be there for all normal installations, but when you do it with mdapstrap, it's missing. Anyway, works like this. I've tried that some time ago. If you're interested in working with Debian ports, that's also possible, and kind of explains how it works with other derivatives. You just tell mmdevstrap how to do it. Wait, the option is in the wrong order. So it's all mmdevstrap options here. Due to backwards compatibility, it actually works that way. Don't use it that way. Another thing that you may want to do with it is sharing a host file system with your virtual machine in order to not having to copy stuff into it and out of it. And Qemu has this virtfs thing, which is not to be confused with, what is it called? Virt.io. Yeah, thank you. It's a completely different thing. On the Linux kernel side, it's called 9p. And we've developed some hook that goes like, whenever it sees a 9pfs available, it just auto-mounts it into media, and the hook customizes the image to do this auto-mounting. So you can plug arbitrary virtfs into it, and it mounts it to, I think, media mount a guest tag, and then your file system is there. Beware that 9p is not part of the cloud image, because who would use 9pfs in a cloud kernel? So you need to use a generic one again. Yeah. Any questions thus far about using it? I count that as no. You can ask questions later. Why do we do this? One of my personal key benefits is rootless. I hate running stuff as root on my machines. And this uses user namespaces, which also uses a setuid binary, yes, but it uses root in a very limited way that is generally acceptable. And you may also be able to use it with fake change root. So this is basically explaining that mmdevstrap is rootless. The other aspect is its fast VM generation. So really simple unstable VM is 1 minute on my system. And that's also advertising features of mmdevstrap. Great. And the third aspect that I really like is it's using Debian as a component source. That means I don't have some storage of VM images that I have to download and trust and like that. My trust root here is Debian archive and the Debian keyring. So when you construct an image, it just verifies that signature, downloads that stuff, and then you have your image. And that makes things rather easy. Yeah. The uniform boot infrastructure is also something I like about it, which is inherited from not doing bootloaders. Why not to use it? It only works for Debian-based distributions. You're out of luck for Fedora, mmdevstrap, right? It only works with extended 4. That's due to the way I extract kernel images out of the root file system. The resulting image has no partition table. It's just a plain file system image. If you want another disk, just plug a secondary disk into your Qemu. There you can do partition tables in the way you want. Yeah. Of course, it's not suitable for testing bootloaders. We had that a few times already. And in order to do debvm, I had to add some mmdevstrap modifications. In reality, that meant that Jochen and Johannes fixed mmdevstrap for me. Thank you. And therefore, it requires a recent version of it. So don't try to do this on Bullseye. With Bookworm and later, it should work. So when you don't use debvm, what could you be using instead? The most similar contender is dqib of Joelle. Forgot the other name. It requires root for image creation. It includes a bootloader. The way it is intended to be used is you download these images that are generated weekly on Salsa and run them locally. So you skip the customization step, and in return, you just get a bunch of images readily available. That may be better for some use cases. I didn't like it as much. Another contender is mkoz, which is way more generic. So this one does Fedora and Arch and lots of other stuff. It also makes it require root for image generation. And that way, the bootloader, partition table, and so on. This one comes from the systemd people and naturally requires systemd. Well, that may not be the worst of things. The images that you can generate with mkoz can also be run as container images. That's a benefit. You can choose whether to run them as VM or container. Yeah, it's native only, so you don't get the cross benefits that also dqib has. Then moving further, some of you are probably using libvirt for local tests, and that's nice. It's more targeted at production environments than development. It integrates with your system, so you have to set up the VMs there, the root and all of that. It does a hell lot of more things, including containers, and felt a bit complex to me. But if I develop debvm for long enough, it probably gains that complexity as well. Then we also have Vagrant. I briefly looked into it and didn't seem to fit my use case. So it seems to be Docker-ish, where you also download layered images and stack them onto another to get the image you actually want. In doing so, it has lots of flexibility and backends and so on. Yeah, it just doesn't seem like you can do ground-up VM creation with it. That seemed really hard. So, like, creating a Jessie image with it seemed rather difficult. And then, finally, you can also delve into the world of containers, which has lots of more options like Docker, Podman, XC, and whatnot. Unfortunately, doing this has been very difficult without root. I think Podman now does rootless entirely in Debian. Yeah, I hope that's getting furthered. And most of the container engines are modeled around this image layering technique where you stack up things and in the end you no longer have any clue where your files come from. And with that, I'd like to end it and thank those who have contributed most to it, which is in particular Johannes for doing much of the groundwork, Jochen for spontaneously jumping in. You can also ask him about it. He's done quite a lot of development, and Arndt and Julia have also contributed at times. So this wouldn't be where it is without these. And also it wouldn't have been there without Frixian sponsoring much of the work. So thanks for that. And now I'm all open to your questions.
Thank you. Oh, lots of questions, and the battery on this microphone is low, so we might need a replacement soon. But for now, my assistant Matilda will deliver the microphone to Thomas, I think.
Thank you. How do you extract the kernel and the init.rd from the ext4 image?
There's x2fs procs, and they have debugfs, and you can script it to do that for you.
It's only read access, or do you use this also for writing after mdapstrap creates the ext4 thing?
No. mmdevstrap creates a tar with everything in the right place, and then I use scanx. mmdevstrap uses scanx2fs to create the file system image, and I only use these tools for extracting stuff in the run step.
How do you modify the ext4 when you call your hooks? If you want to add or modify the ext4 file system without
they are
root?
modified prior to creation of the file system. So the hooks run before there actually is an image, and once the tree is ready, it simply gets turned into the ext image, and then it's done.
Okay, thanks.
Hello, thanks for this presentation. I might have missed it, but did you say something about whether these images are reproducible?
I haven't. That's an interesting question. Admittedly, we have been testing that mmdapstrap does reproducible images, and so I'm pretty sure it inherits the property.
I know it from mdapstrap for tar archives. I don't know it for ext4 file systems, so we should try it later.
Well, the missing step there is that to get it also for scanx2fs, and once you fix that, we inherit it.
Let's check later.
Can you nest it, like to test debvm inside the debvm?
I haven't tried it. If you nest it, you probably get TCG emulation rather than KVM emulation, and that'll make it pain slow. But I don't see why it wouldn't work. Yeah. Thank you, Jochen. So Jochen actually tried it, and as I predicted, it is slow.
So it's limited to X4. So have thought about Btrfs support or any other file system support?
I considered that and thought no. If you actually want Btrfs support, then just plug a secondary disk image into it and be done. But the root file system with debvm is just X4.
Okay.
I also have a question. You said it also does cross architecture stuff. Is it always fully emulated, or is it using KVM where possible? For example, if you do AMD64 on AMD64 or something?
Whenever it sees KVM as possible, it tries to use it. And that's basically it. It knows the BIOC schmackpiming, tries it, checks whether def KVM exists, and all sorts of things to make it fast whenever it can go fast. Except the ARM64 emulation in Bookworm is painfully slow because we only noticed late that you have to pass some crazy option for pointer authentication to make it reasonably fast, and that'll be in Trixie.
Are there any other questions? So I think we can wrap this session up. Thanks again, Helmut. And we'll be back with our next session in about 10 minutes with Holger and reproducible builds. See you soon.